Ladies and gentlemen, it's a pleasure for me to introduce a speaker who does his first appearance here at JFocus, so it's a premiere. Please give a warm hand to Peter Knuts.
Welcome to this presentation where we will build a scalable event-driven architecture from a simple event store, hopefully in 50 minutes. Before we begin, I would just like to know how many of you have actually built at least one system based on event sourcing that you have gotten live into production. So only a few hands. Hope to improve that here today. So who am I? A short introduction. My name is Peter Knuts. I'm a software developer, and I have been so for quite some time. Since 2001. I work at SBAB Bank, and I've been there for a little over 8 years. I work in a team called Tools and Technologies. It's kind of a DevOps team. I'm a backend developer, mostly, but my current role is a DevOps engineer, as I mentioned, and previously I have also been an Oracle DBA, so I have a backend of the backend kind of background. Today's agenda, as I told you in the description, we will be in the first half we will be constructing the basic building blocks of event sourcing, and from these building blocks we will construct a Pojo-based model. And this will take roughly the first half, and then in the second half, we'll connect these building blocks to build an event store. And once we have the events in the event store, we will start to stream them to Kafka in this case. And from there, we will add additional components to turn this into a complete architecture. So that's the plan. So this whole presentation will be around an example using a bank account. We will be using event sourcing in CQRS, so we will have a separate side for reads and writes. CQRS is the command query responsibility segregation. It will be based on microservices, and the examples will be in Kotlin. But if you're a Java developer, everything I will say here today will work equally well in Java. The examples, all the services will be in Spring Boot, and we will use Kafka to distribute the events. So first, the requirements on the command side. So we will start on the side where we have the event store. We will do 3 things in this presentation. We will be able to create new accounts. We will be able to deposit money to an account and withdraw money from an account. And for this, we need to, of course, to check first if an account exists or not. We need to check input data, so we model the amounts as positive values for both deposit and withdrawals. And also, the amount to withdraw must be less than or equal to the current account balance. And this is kind of the challenge when you use event sourcing, because this is not, we'll see this in the coming slide. But keep that in mind. This is not CRUD, so in event sourcing, all data is modeled and stored using a sequence of immutable business events. So if we dive right into one particular account and look at the complete history of events for that account, we can see that first, this account was opened using the account opened event. Then we deposited some money into this account using the money deposited event, and then we withdrew some money using the money withdrawn event. Pretty simple. So far. Events, I should mention also in this presentation, will use the color blue. A quick calculation would give at hand that we now have 1,000 available on this account. But as you also can see, this information is not easily available. And that's a requirement from the previous slide that we need to fix. That will be the first building block. So if we add state to this picture, we can see that before the first event, we can say that the state of this account was null, and state will use the color red here. And after that event has occurred, then we can say that we have a newly created empty bank account. And from there, we deposited some money, and now we have 1,500 into the account, and then we withdrew some money. So now we're at the end state of this. That's the current balance of this account. But this is the full history of the corresponding state. Revision number that I have on top here, that is just the sequence number of this particular event within a single bank account. So first event will have revision number 1, second 2, and so on. And this will be important later on in the presentation. So the first building block we need is a way to get from a sequence of already existing events to the current state. And how can we do that? We can implement an interface like this. I called it the domain state. It contains a single method on event, which takes the current event as an argument and returns a copy of itself where the relevant parts from this event has been used to update the domain state that we return. So that seems pretty simple. And that will take us from an existing bank account to the end state. And we do that by calling this onEvent method for each event in this sequence until we reach the end. But we do, however, have an initial condition where this will not work. Because if we tried in this state, we will get a null pointer exception. So here we need to do something different. So what we need to do here, at least in this setup, is to add a constructor that takes this first initial event as an argument and constructs this event. So the class that implements this interface should have this constructor with this signature. This will be clear later on in the presentation, how this is used. So this is a complete model then, the state event handler. So if an account doesn't exist, we take the first event and call and try to find a domain state class that has this constructor, use that constructor to create an account, and then we just call the onEvent method repeatedly until we reach the end state. So let's look at the complete implementation then in Kotlin. And this should be pretty simple. So I added a primary constructor here at the top just to be able to more easily test this class in unit tests. It implements the domain state. And here on top is that constructor I just told you about. So it takes the account open event as an argument. And in this case, we just need to construct this in the kind of default state here with a balance of 0. We override the onEvent method to handle the remaining event types. So these two in this case. And here we delegate to this on method. And in Kotlin, a data class is similar to a Java 17 record. So then we can use the copy function there to update the balance with the data from the event. We should, of course, write unit tests to verify this functionality. So in this case, we test that the constructor will work. So we create an event, an account open event, and send in a unique account ID, which is what this default constructor there does. And then we send this to the constructor and then just verifies that the balance is 0. So pretty basic. And we should also test, of course, the remaining event types. So in this case, we need to construct the account first, and then we call the onEvent to see that this particular event will update. This step will work okay. So it's one step at a time. So here we update from an account with a balance of 0 to 1,500, and that seems to work. So building block number 1 that we need is a way to get from a list of existing events to the domain state. And the question mark here in this lambda expression is denotes in Kotlin that this is a nullable type if you're a Java developer. So there could be an empty list. So now we need to go from we have an existing list of events, but how did we actually create these events in the first place? So then we add this green box here in the middle, and I will use the color green for commands. So if we have an account that doesn't exist, we can issue an open account command, and that will emit an account open event. That event will then in turn move this state to an empty account, and from there we can deposit and withdraw money using the same kind of logic. So if we take a closer look at this image, we can see that whatever this green thing here is in the middle, it seems to be always something that takes this red box here, that is the domain state we just implemented, as an input, and it returns an event. And in the first case there, it's null, so it's a nullable state as input. So this can be expressed as something that takes the domain state nullable and returns an event. And for more, you could have more complex business logic than in this case, and then it could also be a list of events. So this is actually your business logic. Let's look a little bit closer into this green box. If we zoom in, we can see that it actually consists of two things. It's the command, and the command is the kind of the pure data part that you send in. So in our case, it could be that, well, I want to withdraw 500 from an account with this ID. So that's only data. And the command handler is what then should implement this lambda expression. So it takes the domain state as input, and then you can validate the business rules in that command handler to say, can I withdraw 500 on this account, given that it's now in this state? If everything is okay, you return an event or a list of events. And if any of your business rules fails, you throw an exception. So let's look at some code. If we start from the simplest command, the open account command, we send in the account ID that we want to create. So that's not done in the command handler, so random ID here. And if we look at the open account command handler here, that's the thing that contains the business logic. So it takes as an argument here in the constructor the state of this particular account. And then you can call this method whatever you like. It's supposed to implement this lambda expression, but I called it handle. It takes then the open account command as an argument, and it's supposed to return an account open event if everything works well. And here in the handle method, that's where your business logic goes. And in this simple case, I only need to check one thing. I need to check that an account with this particular ID doesn't already exist to avoid creating duplicate accounts. And I do this by checking the current state of this account that I sent in. So that is supposed to be null in this case. And if it isn't, this check in Kotlin will throw an illegal state exception with this message. If everything is okay, I return an account open event. Let's go from there to the most complex business case that we need to handle in this case, but the structure is very similar. So in the withdraw money command, we now also need to send in the amount we want to withdraw. Handle method, everything seems pretty similar to the previous case. But there we need to do some more checks. We need to do the opposite check of what we just did. So we need to check that this account now is not null, it needs to exist. Otherwise we would deposit the money, withdraw the money from like void. We need to check that the amount that we send in is modeled as a positive value. And also here comes this thing that we spent a lot of time trying to solve. We need to check that the current account balance is greater than or equal to the amount we want to withdraw. So 3 business conditions to check before we can execute this business logic and return the money withdrawn event. Let's write some unit tests to verify this. So in this case, this is the happy case. We create an account ID and an account. The current balance is 1,500, and we want to withdraw money from this account, in this case, the amount 500. So we create the withdraw money command handler, send in the account with 1,500 on it, and we call the handle method with this command. This should work, so we should have an event in return, and we check that the account ID of this event is correct, and also that the amount we set in this event is correct. That's all we need to do. If we go on and test the not so happy cases, so everything in this is exactly the same, but we now try to withdraw 1,600 from this account, and that shouldn't work. So in this case, we instead accept an exception to be returned. And we check that the exception message is insufficient account balance. And in a similar setup, you should also test the remaining types. So this is building block number 2 of the 3 that we will use. So command and command handlers, we need them to execute business logic on the current state. And they come in 2 variants. You take the domain state and return an event, or the domain state and return a list of events if you have more complex business logic. But wait a minute. What exactly is an event? I never told you that. This is going to be an event store later on. So we need some kind of format that can be serialized and deserialized, because we need to store these events long term. And from what I have seen, most people seem to just go for JSON because it's familiar and widely adopted. But any of these formats would do. If we zoom into the 2 at the bottom here, Apache Avro and Protobuf, they are more custom made for this kind of purpose, actually. I won't go into Protobuf here, but it has similar features. If we look at Avro, Avro is a binary format. It's very compact and efficient, significantly faster than JSON. It has support for many programming languages. So you can send the data, for instance, in plain Java, and you can receive them in C# or what you have. It offers support for something called custom logical types. And that is what I used in this example. I just used account ID as any type. So you don't have to wrap and unwrap your value object types to strings and from strings and so on. And it also has support for null safety. If you modify this velocity template currently that is used to generate these classes. But I have contributed that back into the Avro project, so hopefully in the next release you will be able to use a Maven compile configuration instead to get that same functionality, because this is a little bit messy. But it was merged 4 months ago, and there's still no release of that. It's often used for data sent over Kafka, and it has, and this is the feature I was looking for when we picked Avro, it has built-in support for schema evolution. To get this to work, you also need to add something called the Confluent Schema Registry. So you need a central place where you place these schemas. And we need that to enforce the compatibility rules, what is called backward transitive. And with this setup, we get what's in event sourcing called upcasters. We get them built in, and we can check that at build time. And if you want to run and test this locally, you can use the mock schema prefix, so you don't need to set it up just to start to mess around with this code. Then you will get an in-memory representation. You can also run it in Docker. So this is quite important, so I will go into a bit more detail about this. So say we're communicating over Kafka, a producer here down to the left and a consumer up in the right. They both use the same schema of this count opened event. Contains a single field, the count ID. So this is trivial. They can communicate because they are both using the same contract. Now we decide that we want to add a name to our account. Maybe name it your dream house or whatever you're saving for. So we add a name to this schema. And now, as you can see also on the top here, that the schema of the consumer got updated. So this name attribute was added as an optional field. And the consumer is updated. So the producer is now sending still schemas using version, or events using schema version v1. But the consumer is now receiving these events using schema version v2. So it will receive these events with a name set to null. Now we're ready to take the next step, so we can start sending these v2 events as well. And that works also. So now the consumer can receive both v1 and v2 of these events. And maybe I should go back one step. So this is called backward compatibility. So you backwards compatible one step. So if we move forward to the next step, we add a type to this bank account. Maybe you need to add support for fixed and floating point interest rate types, and you only now have support for floating point type, so you can add that type as a default, because all the existing accounts will have that type. And again, as you can see, the consumer was updated first before we can start using these events. So now it can receive events using version V1 and V2 as well. And now we can start to send these V3 events. So why am I talking about Kafka here? We tap into this functionality, but instead of sending these events over Kafka, we serialize them and store them in the database instead. So now in the database you have these V1, V2, and V3. But since we're now ourselves the consumer of these events, and we're always using later and later versions as time goes by, we can read up these events, deserialized and upcasted correctly from this event store. I will explain this a little bit further, because we have had a bit of problems with this, even if this is built in. So I will move to a more familiar domain for most developers, perhaps. So if we go to a regular database and insert into customer tables with 2 columns, an ID and a name, we insert the value 1 and Matthias Karlsson, of course. So this is similar to storing an event in the event store with this structure. We then can select from this table, and no surprises there. So this is reading back the events from the event store. And this is a schema update. So if you do an alter table and add a column, I think you all know why you cannot set this to a non-null type now. Because the database would not allow you, because it uses this backward transitive mode. And that's what all databases do. So if we now select the exact same row that we inserted, we can see that we now get it back. And going from step 2 to step 4 here, that's an upcast in the terminology of event sourcing. So schema update and alter table, and this is an upcast. And you get that in any database, but using this technique, you can also get it in the event store. So an event, in this case, is just a type alias in Kotlin for specific record, Avro specific record. So if you're using Java, you would use specific record instead. An example, you specify these in JSON format, and you can read up on the documentation there. Here it contains, this is the money withdrawn event. It contains 2 required fields, and there I have this logical type as well. So it's backed by a string, an Avro string, but it's using my logical type account ID, so I don't have to wrap and unwrap this type when I use this event store. So building block number 3, the last building block that we need automated serialization and deserialization of events with built-in upcasting. And this is going from a list of blobs, so you can use anything that can store a blob, and you can go to a list of upcasted events, and the other way around. So let's connect these 3 building blocks now. So at number 1 here, a command comes in. That's what you want to do. You send a command to maybe withdraw some money. You send it to the command handler here, and as you remember, commands are in green. The command handler will need the current state of this account in its constructor. So that will trigger the flow here at number 2. So we read up all the events using this account ID from the event store, and we get back a list of blobs. So we read them in the revision order that I mentioned previously. We use Avro and the schema registry to go from that list of blobs to a list of upcasted events. And then we use the domain state logic in the building block number 1 here that we discussed in the beginning to get the current state. And then we send that into the constructor of the command handler. And we execute the logic in the handle method to check if you can apply this command given this state. If everything works well, the happy case, then we emit an event from this or return an event from this handle method. And then that will trigger flow number 3 here. So we go the other way and serialize this event to a list of blobs using, again, Avro and the schema registry. And then we append this list to the event store from the next revision number from what we read up there in step 2. Make sense? So that's the complete flow. And yeah, I guess any framework will use something similar, but you may have to do the upcasting yourself. So that's the first part. Now it's time to actually attach this rather simple logic to an actual event store and start to do some production-like logic. So we attach it to the SBAB Spring framework, and I will give you a link at the end of the presentation. It's free to use, and the full example that I will show you here today will also be there. From there, we will go to an event store, so we will store this event in a database, and we will then stream these events to Kafka. So we'll turn this event store into an event stream, and from there, add additional components. So what you get back when you start up this logic with Spring is you get back an implementation of this domain or this command service. And it has a generic argument, the domain state. So in this case, it's our account that implemented this domain state. It contains 2 methods, and they're pretty simple. So if your business logic in the command handler return exactly one event, you should use apply. And if it returns a list of events, you should use apply list. Otherwise, they are identical. So the first argument is the unique ID of whatever you're working with, the account ID in our case. And the second argument is this lambda expression that contains the business logic. So let's look at the complete implementation in this case, how to connect this. So you inject the command service with the generic argument of the account. That's the type. And these are all very similar, so I will just go through one of them. So you can call the method whatever you want. We called it apply in this case. You send in the command, and remember that was the pure data part. So you send in, I want to withdraw X amount from this account. You expect just one event in return in this case. You call the command service apply method, and you give it the unique ID of the account because it needs that to read up the current state. So that's the first argument. And the second argument is this lambda expression that contains your business logic. And that's you get in the current state, and you just hand over that to the constructor of the command handler and call the handle method with that command. And that's all will look similar to this always. So if we now want to use this command handler, you can use it both for handling synchronous and asynchronous requests. So in this case, we connected to a REST controller to be able to deposit and withdraw money and open new accounts through a REST interface. So the open account takes nothing in as an argument, and it will return the account ID of the generated account. So we construct the command. We call the command service apply method with this command and return the account ID. And as you can see, for instance, in the deposit money example, I can make it look like REST. So I send in the account ID as a path parameter to the deposit endpoint. I take that parameter, I send in the amount in the body and construct the command and call apply. So that's all you need to do. For this to work, you need a minimal amount of Spring configuration. So you need to point to the schema registry where you keep your schemas. But you can use auto-register, and you can use the mock prefix, as in this case. You need a data source where you store the events. In this case, it's the JDBC in-memory database, H2. And you also need to set up the structure of this database, but you can just point to the built-in changelog, the liquid-based changelog. You also need to set 1 or 2 properties. You need to set the namespace for your events in the schema registry, and this is also the topic that we'll later use to distribute these events. And if you want to use reflection to find these constructor for your domain state classes, then you will set this property as well. So this, and I call it framework now. It's I don't know what needs to be in there to call it the framework, but it's, I would more say it's 600 lines of reusable Spring code. It's based on Spring Boot 3. It stores the event in a relation database. It handles concurrency and transactions for you, so you don't have to worry about that. Everything you do inside a command handler will be done in a transaction, and if it fails, you will be given the new state. If someone updated the state before you, you will be given a new state, and you will get another try, and that will be handled by the framework. And it also publishes these events that you store in the event store to the Spring application event publisher. I usually call it the event bus. So if you use the transactional event listener, you will get notified when an event has been successfully stored in the event store. And if you, for some reason, want to know exactly when it's called, you can use this event listener, but then it might be rolled back later on. So it's now time to go from an event store to an event stream. And I saw later on today there will be a talk on Kafka Connect, and this is what we are using to distribute these events. They are currently in the database, but if we use Kafka JDBC source connector, we can distribute them onto Kafka fairly easily. So we set the incrementing column name that Kafka Connect will use to find new items from this database table. And we map the aggregate ID from the database table to the Kafka key, and we map the payload, that's the blob there, just to the value because it's already in this Avro schema registry format. And we take the revision number and send that as a revision header because that is also information we need. With this in place, that's the first step to turn this into a CQRS-based solution, because now we have the events in the event store, and we can use Kafka Connect to distribute them onto a Kafka topic. So we could start building this account query service, the read side of this solution. However, it's a really good idea to put a component here in between, an account event stream processor, or the generic term would be event stream processor. And what you can do with this component is you can, for instance, the first use case is just sending them over to the account query service as was done just previously. But you can also map events. So if someone else wants to know that an account has been opened, another service might need to know that. Then you can map that event type onto some external event type that you can send on what I call like integration events. So you can notify your surrounding when something happened in your on the command side. So when that is created, you can map that. You can also, for instance, if you have sensitive data, you can mask fields in there. You can also go in the other direction, so you can listen for events from external sources, and you can turn them on into commands, which you then send asynchronously back to this account command service. And maybe you need to stream them to like a data lake internally in your company in a raw format. You can do that as well. So now we're on the query side. So there we have two requirements. We should be able to get an account with balance based on ID, and we should be able to get a list of accounts. And this is more of a good practice, so if you want to solve this in another way, you can do so. But the first thing we do is to set up a bridge between Kafka and the internal, again, Spring application event publisher. And we listen to Kafka events and then just hand them over to the Spring event bus instead. And here the events are in a shared library, so we can just import that library and get the events upcasted here as well. And now this is the consumer of the consumer, so you need to update this service first if you do schema changes. It's later on in the chain. With this solution, you will be able to test this logic without having to involve Kafka. So you can just skip that on-event part. And if you have a Spring Boot test, you can call publish event directly and just say, I'm not testing Kafka, I'm not testing Avro, that's not my business, that will work. We can then listen to these events on the other side in this service. So you use one event listener for each event type. And in this case, they go into a database table again. So for the account opened event, we will save that to the database because it shouldn't exist in this case. So we save it with a balance of 0, and for the remaining two types, we use this project method. And what it does is just reads up this event, this row from the database, update the balance column using the amount from the event, and saves it back. So if we now want to expose this information in, and in this case, we're using GraphQL with Spring, you can do something like this, and it's you can get very good performance if you use GraphQL, and it's very also dynamic. If you need to change things in the UI, you can get whatever data you want, and as a backend developer, if you want to performance optimize this, you can do that very easily. So in this case, you can get an account by ID, and as you see, I delegate this to the account repository find by ID. And with a couple of more interfaces on top of this repository, you can get a list of pages as well. So you can test run this. You get a graphical interface. It's called graphical when you start Spring with the GraphQL. So in this case, it's a GraphQL query here on the left, and you send in in this case, the page size and page number, and you get back a list of accounts. Yeah, you see the tab there, you can get the pre-formatted query for the account as well. So with that in place, we can now read accounts and get a list of accounts from the query service, and we can send commands to the command service. So we're now ready to add a UI on top of this. However, we will run into a problem, or if you start new, you will run into this problem. So if the UI sends the command to the command side, it then stores an event in the event store, and it immediately returns. If the UI then refreshes this information and goes to another service to do so, we are using a distributed system here with events, so it will take some time for this information to reach this query side. So if you immediately at point 2 here refresh the UI, that data may be stale because, yeah, as you can see, it's there in point 3. So what we need to do to solve this is we need to add a single point of access for the UI, BFF, backend for frontend, and that's a good idea anyway. But here I will show you the use case for this to solve this. So in this case, the UI sends the command to the BFF, which sends it to the command service, and it responds with 2 headers. It responds with the aggregate ID header and the revision number of the latest event that was produced by this command. The BFF then takes these 2 headers and converts them into some information that you can use to determine if this information has reached the destination. So in this case, it will use the poll URL, and as long as it returns a 2 or 4, that information has not reached whatever service you're going to use to refresh this data. And when it turns to 200, okay, then you know that the data is there and you can refresh the UI. And the good thing about this is they can use this poll URL in for instance, an Axios interceptor in one single place in your UI, and then it will behave as you're used to. The eventual consistency problem will seem to not be there. So when you get the response, the data is available. And you could set up WebSocket or do something different, but you need the aggregate ID and the revision number, and the BFF can know this. So that all seems fine, and we are able to send commands into this service and save events, and life is happy. But then this guy from the marketing department comes by your desk and wants to ask you a couple of questions. They want to run a campaign called We Double Your Money. And in the fine prints, you can see that it's only valid for new accounts, and the money must be deposited within 24 hours. Max amount is 5,000, and it's paid out after 7 days after the account opening dates. So you can immediately see that this doesn't really fit into the command event cycle because it spans like 7 days and it's several steps. So you ask him to get back and book a meeting, and then you present him with this. And this is called BPMN, Business Process Model and Notation. So it's a way to model business processes. And here it's a start event, and yeah, maybe I should describe it instead in when you talk it over with this guy in the meeting, you want to make sure that you have understood what this process is supposed to do, or this campaign. So as an account is opened, we will wait for 24 hours because you need to deposit the money within these 24 hours. And then we have a service task that will check the current balance of that account at that point. And then we have an additional 6 days of delay, and then we deposit the campaign money back. And as you can see, we see that the max amount is 5,000 in this case, and this will end the campaign logic. And the fine thing with BPMN is it's not only is it a notation, but it's also an implementation. So I want to show you a couple of examples because this will only scratch the surface of what you can do in BPMN. But the account opened there, if you want to start this process when an account is opened, you can do like this. So you inject the runtime service, which is the hook back to the process engine. You add this transactional event listener that we can use to listen to events when they are successfully stored in the event store. So the on-event method will then be called, and we can use the runtime service to start this process, and I called it the double money campaign process. And we send in the account ID, and this time I need to get the string out of it. So that will start the process, and then if we look at, that's the interaction from the event store to the business process. If we want to check the other way around, if we reach this service step, then you need to implement a Java delegate. And again, you use this same account command service that we used before, and you get in the hook to the process engine here as the delegate execution. So you extract the business key that we put in before, and you extract the balance that we stored as a variable in the previous step, construct the command, call the apply. And it doesn't become much more complicated than this. So with this picture, you can start to communicate with the business side, and this is also the code that will execute. This is called the Saga orchestrator if you use it in an events sourcing solution, but it's called the workflow engine if it's used outside of event sourcing. So now the solution looks like this, and you can use this workflow engine either inside a service if it's mostly communicating with the subdomain in there, or you can use it as in the lower right corner here. You can listen to integration events and have it completely separate. So for developers, if you use this framework, it's much easier, I think, to get started with event sourcing. The core business logic, as I showed you, can be implemented and unit tested without any framework dependencies using fast and simple unit tests. It uses standard technologies off the shelf, and they are all free to use. And if you don't like one part, if you don't like GraphQL, you can just use something else. In the front end, I would recommend take a look at TanStack Query if you use React, because that's really a fantastic way to handle state on the command side or in the UI. So to summarize, event sourcing. If you're using CRUD to store your data, you're most likely using some parts of that data, because the U and the D means update and delete, so your data is gone. So if you use event sourcing, you will keep more data and be able to make better business decisions. Also time, a couple of things. If you have a separate read and write side, they can be optimized for its tasks. So on the read side, you do not want to have a compromise between reads and write. You want your users to get the data immediately. And if you have a separate read side, you can optimize for that. And also, if you stream these events in real time, as I showed you, if you for instance, want to detect potential fraud, doing so the night after your nightly batches has executed, by then it may be too late. If you distribute these events immediately, you can also act on them immediately. So you may be able to stop this attempt. And also this last point here, complexity. As you saw in my example here, complexity is what usually kills large software projects. But in this setup, you can test the state changes for one particular event at a time. All your commands will be separate from all other commands, so it's no more complicated to write command and command handler number 100 than it was writing the command handler, the first one. Also, raising the abstraction level with BPMN and being able to communicate complex workflows with the business side, I think will significantly help to reduce complexity even further. So using this full-featured workflow engine to handle orchestration in event sourcing, I think is key to success. So, that's all for me. We're hiring if you want to have a look at the jobs there. And this is the link to the event store with this complete example. And also this reusable part is called Spring Boot Event Store, as a name there. That's the module that is reusable inside that. But you can use the blueprint here in this that I showed you. It's a complete architecture. And there you can replace my events with your events that you are modeling. And you can replace my command and command handler with your business logic. And the overall architecture will remain more or less the same. And this is what I did in this presentation, because we did something completely different at SBAB too. But the architecture is exactly the same. So do we have some time for questions? Yes? Yeah, either if you do that in a REST interface, you send back. Yeah, okay. If you get an exception in the command handler, what do you do then? In the case where you have a synchronous call, then you can send that to the user saying that this didn't work. And you have to use something similar in if you communicate over Kafka, for instance. But it will be handled naturally by whatever logic you're using. So you may send it to some error queue, or you may write it in the log. Yes?
Well, I was wondering if you have, like, the one problem with event sourcing is like GDPR and the right to be forgotten.
Yes. Good question. GDPR, in event sourcing, GDPR may be a huge problem because you cannot delete data. We store the event in a relational database just because of that bank requirement for being able to actually be forgotten. So when we distribute it to Kafka, this is 7 days retention. So after 7 days, that data will be gone, but you still have the data in your database. And there you have control. So you can go in and delete all the events for a particular account when that, if you don't need them anymore or for legal reasons need to remove them, then you can do so. Yes?
When dealing with event sourcing, it is really important to take care of the order of commands and same order of events. But if you're going through the REST interface, there could be some concurrency in the commands coming from the same aggregate. How would you deal with it?
Yes, concurrency. I had a, I don't know if I have this, I have, yeah, so this is the picture in concurrency, how this is handled. So if two commands come in concurrently, then only one will succeed and the other one will fail. but the one that failed will get a retry on the new state that the first command caused. And if that succeeds, then it's okay. And if you don't want this to succeed, you can just keep track of the revision number that you're on if you need to see the latest state. And I will be in the SBB booth outside in the hall if you need to. Perfect. Come visit me.